Hi students, welcome to KFA Academy. Okay, last class we discussed various concepts about acid and base. Okay, in this class I'm going to explain about conjugate acid and base. So for better understanding, we are going to discuss some examples. So conjugate acid, base pair. So don't get confused. As per Lowey concept, acid, what is meant by acid? Substance donate H plus, that is known as acid. So after donating H plus, what is left, that is known as base. For example, HCl is acid, so it will donate H plus. After donating H plus, what is left? Cl minus. So that Cl minus is known as base. Here HCl is known as acid. This two pair is known as conjugate acid base pair. Conjugate acid base pair. Okay, so we will discuss some more example. Base, what is mean by base? As per Lowey concept, H plus acceptor. H plus acceptor is known as base. So consider example NH3. So NH3 that will accept H plus. So what will happen? It will become NH4 plus. So after accepting H plus, it will become acid. So NH3 is base and NH4 plus is acid. Okay, this 2 is known as conjugate acid base pair. So conjugate acid and base pair. I hope you understand. Okay, we will discuss some more example. Listen here. Okay, I'm having HCl and H2. So in this, which one is base, which one is acid, that we are going to find. So listen very carefully. HCN, you donate H plus. After donating H plus, what is left? Cn minus. H2O will accept H plus. So it will become hydronium ion, H3O plus. So HCN is acid. H2O is base. Okay. So after donating H plus, what is left? That is base. After accepting H plus, it will become acid. So this is conjugate acid base pair. And for this is a conjugate acid base pair. So acid donate H plus, base will accept H plus. Okay, we will discuss more example for better understanding. Okay, CH3 COOH plus NH3. Okay, in this example, which one is acid, which one is base? This is acetic acid. So this is acid, this is base. As per this concept, acid will donate H plus. So CH3 CO minus, what is left after donating H plus? Base that will accept H plus. After accepting H plus, it will become NH4 minus. So listen here, CH3COH is acid. After donating H plus, what is left? That is base. Okay, base accepting H plus, that will become acid. So the conjugate acid base pair, listen here. This is acid, this is base, conjugate acid base. So like here, NH3 is base. After accepting H plus, it will become base. Acid, NH4 plus acid. This is conjugate acid base pair. Okay, so we will discuss some more example for better understanding. Listen, see the example of ammonium ion, NH4 plus H2O. Okay, which one is acid, which one is base? So already we know NH4 plus acts as acid. Okay, after donating, so acid means donate H plus. So after donating H plus, what will be left? NH3, that is base. Okay, H2O that will accept as H plus. So it will become hydronium ion. So that is acid. So here NH4 plus is acid, H2O is base. Now we can integrate. NH4 plus is acid. After donating H plus, it will become NH3. So that is conjugate acid base. Like H2O accepting H plus. So it is a base. After accepting H plus, it will become acid, hydronium ion. I hope you understand about the conjugate acid base pair. Okay, so now we will discuss about Lewis concept. Some more example with the Lewis acid and Lewis base for better understanding. So Lewis acid, already I told you, Lewis acid. Acid means electron acceptor. It will accept pair of electron. Okay, electron acceptor. Simply remember AA, electron acceptor. So it will accept pair of electron. Base, it will donate pair of electron. Okay, so Lewis base. What is mean Lewis base? Lewis base is nothing but say electron donor. So, however, it will donate pair of electron, at least minimum one pair of electron it will donate. Minimum one pair of electron. Then it will be considered as a Lewis acid or Lewis base. Okay, Lewis acid electron acceptor, Lewis base electron donor. So, based on this, we will discuss some other example. What are the things, what are the compound will act as Lewis acid? Generally, Lewis acid, it may be positive ions. Okay, it may be positive ions. It may be positive ions. Example, Cu2 plus. Because Lewis acid means electron acceptor. When it will accept electron, electron deficient species. So all positive ions are electron deficient species only. So it will accept an electron. Then second one, less than octet. Less than octet. So BF3 is there. The central atom is boron. Boron is surrounded by only 6 electrons. So less than octet, BF3, BCl3. And molecules with a double bond. Molecules with a polar double bond. That also act as Lewis acid, polar double bond. The best example, CO2. So expandable valence cell. Some of the central atom can expand its octet, more than octet. So expandable. So expandable valence shell. This is also act as Lewis acid. Best example for expandable valence shell, phosphorus pentafluoride. Okay, so Lewis acid means electron donor. It will donate. Sorry, Lewis acid electron acceptor. AA, remember. So we will discuss some example. NH3 and H plus. Which one is Lewis acid? Which one is Lewis base? NH3 has one lone pair of electron. So it will donate the lone pair of electron to electron deficient species. And it will become NH4 plus. So this is donor, this is acceptor. This is Lewis base. This is Lewis acid. So like NH3, BF3. NH3 has one lone pair of electron. So it will donate this lone pair of electron to electron deficient compound. BF3 is electron deficient. So NH3 will donate a pair of electron to BF3. So what will happen? It will form an adduct. Actually, it will form coordinate compound. So detailing we will discuss in coordination chapter. Okay. So H2O. Okay, H2O will act as, listen here, H2O. The central atom has, okay, central atom is oxygen. It has 2 lone pair of electron. So it will donate electron deficient species, Cu2 plus. What will happen? It will donate a pair of electron to here and it will make a complex. So Cu H2O 4 times. So these are the things. Okay, what is milk complex? So these are the things we will discuss in upcoming classes. I hope you got clear idea about Lewis acid, Lewis base, and a conjugate acid, conjugate base. Okay, thank you, Sula.